close my eyes and I can see a world that's waiting up for me, that I call my own. Through the dark, through the door, through where no one's been before, but it feels like home. They can say it all sounds crazy. They can say I've lost my mind. I don't care if they call me crazy. We can live in a world that we desire. 'Cause every night I lie in bed, the brightest colors fill my head. A million dreams are keeping me awake. I think of what the world could be, a vision of the one I see. A million dreams is all it's gonna take. Oh, a million dreams for the world we're gonna make. However big, however small, let me be part of it all. Share your dreams with me. You may be right, you may be wrong, but say that you'll bring me along to the world you see, to the one I close my eyes to see. I close my eyes to see. Every night I lie in bed, the brightest colors fill my head. A million dreams are keeping me awake. I think of what the world could be, a vision of the one I see. A million dreams is all it's gonna take. Oh, a million dreams for the world we're gonna make. Oh, a million dreams for the world we're gonna make. I'm a pool
Welcome everyone to another year of NASA's International Observe the Moon Night broadcast, coming to you from NASA's Goddard Space Flight Center in Maryland. I'm your host, Lauren Ward, and I am so excited to be part of this celebration with you. International Observe the Moon Night is a time for everyone on Earth to observe the moon, learn about lunar science and exploration, and reflect on the many cultural and personal connections we have to the moon. If you go to our website, moon.nasa.gov/observe, you can find lots of information and resources about this event, including our map of lunar observers all over the world. If you register, you can even add yourself to this map. Every dot you see is a person or group of people observing the moon with you. We also have recommendations of activities you can do at home, links to videos, our moon maps made especially for today, and a new NASA Lunar Citizen Science project. You can also share how you're observing and find out how others are participating around the world on social media by using the hashtag #ObserveTheMoon and by checking out our Flickr gallery. For this year's broadcast, we have a wide variety of videos, visuals, and information to share. We're going to kick things off with a video about NASA's Lunar Reconnaissance Orbiter spacecraft, which has been collecting an incredible amount of data on our moon since 2009. In fact, International Observe the Moon Night was inspired by the interest in events celebrating the arrival of LRO and its sister mission, NASA's Lunar Crater Observation and Sensing Satellite, or LCROSS. The information from LRO has led to many scientific discoveries that are helping us better understand the moon's history, composition, and potential for future exploration with the Artemis missions. This video highlights some of our recent discoveries that involve impact craters, volcanic activity, and the moon's south pole. Take a look.
Since its launch in 2009, NASA's Lunar Reconnaissance Orbiter has been gathering incredible amounts of data about the moon. This information has led to many scientific discoveries, shedding light on the moon's history, composition, and potential for future exploration. One of the most heavily used instruments on LRO is its high-resolution camera system, which is able to capture incredibly detailed images of the lunar surface. By analyzing these images, scientists have been able to gain new insights into the moon's geology and its evolution. For example, LRO has provided new data on how the lunar surface changes as a result of the formation of impact craters. During its years orbiting the moon, LRO's camera has captured the immediate results of meteorite impacts on the surface, such as scattered debris and ejecta patterns on the surface. And since the moon lacks an atmosphere, these newly formed craters remain essentially untouched over many years, allowing LRO to continuously measure and collect data on them. This means scientists can analyze a crater formed a year ago and use it to learn about craters that formed millions or billions of years in the past, giving us clues about the moon's geologic history. We can't replicate this type of study on Mars or on Earth, since atmospheric conditions like wind are rapidly changing the surface. The moon is therefore a unique environment for learning about our solar system. Another major focus of LRO's mission has been the moon's south pole. This region is of particular interest to scientists because of the detection of water, which will be a vital resource for future missions to the moon. The data LRO has collected allows scientists to create detailed maps of the South Pole, leading to the discovery of large regions that appear to contain significant amounts of this water. These discoveries are important because they could help make future missions to the moon more sustainable. Instead of having to bring all their own water with them, astronauts could potentially extract water from the lunar soil and use it for drinking, cooking, and even rocket fuel. The Lunar Reconnaissance Orbiter spacecraft is also equipped with a suite of scientific instruments that aid in exploration, including a laser altimeter called LOLA that is able to measure the precise elevation of the lunar surface. Using LOLA, scientists have been able to create the most accurate map of the moon's topography to date, as well as improved lunar gravity models, both of which will help future exploration efforts. Finally, data from LRO has helped us better understand the composition of the lunar surface, shedding new light on the moon's history. The data has shown that a wider range of compositions of volcanic rocks exist on the lunar surface than previously thought. We have found compositions of rocks that are not part of the Apollo sample collection, and evidence for volcanic activity that may have occurred only 50 million years ago. That's 950 million years after scientists had previously thought it ended. This information helps us piece together a geologic history of the moon from just after its formation to the present day, information that will aid in understanding future samples collected by Artemis astronauts. Thanks to the incredible data gathered by the Lunar Reconnaissance Orbiter, NASA and the scientific community are making incredible strides in our understanding of the moon. With every new discovery, we are one step closer to unlocking the secrets of our closest celestial neighbor.
Hola, soy Karina y soy de Barranquilla, Colombia. En Barranquilla tenemos una canción dedicada a la luna que dice: la luna de Barranquilla tiene una cosa, qué maravilla.
We are very excited to be celebrating International Observe the Moon Night with NASA.
Hey there, we are the Ramin Su and we're saying hello from Madagascar. In our language, Malagasy, the moon is called
Bulana.
We have this lovely tradition of calling our parents Masonja Mambulan.
Sun and the moon.
So next time you observe the moon,
Send your love to the people you cherish the most. Happy International Observe the Moon Night. Mwah.
Mwah!
Hi, I'm Isabel from Melbourne, Australia, and we like learning about the moon at school. Happy International Observe the Moon Night!
Hi, I'm Henry from Melbourne, Australia. I like Happy International Observing the Moon Night.
Hi there. My name is Anne McLean, and I'm an astronaut who has lived and worked 250 miles above the Earth's surface on the International Space Station. Today we're going to be turning our eyes toward the moon and learning more about what causes the moon phases. Now, when you're looking up at the moon from the Earth, you'll notice that it looks different from day to day. We call these differences the phases of the moon, and they cycle through every 30 days. Let's check out a demonstration of the moon phases here on the ground. We're going to pretend his head is Earth, letting him view the moon as you would from your home. The ball in their hand is going to represent the moon, and the light source is going to be our sun. Keep in mind that while the moon is orbiting Earth, Earth is also rotating on its axis and slowly orbiting the sun. Now, looking from our outsider perspective, we can see the moon is still whole the entire time it is orbiting around Earth, with the side facing the sun always illuminated and reflecting sunlight. Let's take a look at what he is seeing. As you can see in the photographs from Earth's view, the reflection of sunlight looks quite different from this angle, since we are only able to see parts of the reflected sunlight as the moon moves around Earth. This is what causes our moon phases, as the moon orbits around Earth every 30 days. There are names for each of the phases of the moon's 30-day cycle. When the moon looks completely dark, we're experiencing a new moon. This is the beginning of the 30-day cycle. It will move through a waxing crescent phase until it is a first quarter moon. From here, we will see a waxing gibbous until the moon appears fully illuminated. You might have heard this phase before. This is what we call a full moon. After this phase, the moon will go from a waning gibbous phase into a third quarter moon. After the third quarter moon, it will become a waning crescent until it returns to a new moon. On the space station, we see the same moon phases as we do on the Earth's surface. Since the space station is only 250 miles closer to the moon than we are here on the ground, astronauts on the station have the same perspective you have, but don't have the Earth's atmosphere in their way for photographs. Astronauts currently on the space station actually use the moon's phases to collect research that will help NASA with the Artemis program as we work to go forward to the moon with our astronauts by 2024. So, the next time you're outside, take a glance up at the moon to check out what phase it's in. Are you interested in seeing the space station fly by as well? Ask an adult to help you sign up for Spot the Station at spotthestation.nasa.gov. Thanks for learning with me today. See you next time.
This evening, you'll see a first quarter moon, a great phase for viewing through a telescope or binoculars. The rugged lunar terrain really pops out along the terminator, which is the line between the light areas and the dark areas on the moon, basically the line between day and night. Even without binoculars, you can observe the terrain that's lit up by the sun and where shadows typically cover. No matter how you observe the moon, you're bound to have questions about what you see. In this next segment, NASA scientist Jacob Bleacher answers some questions we've gotten on social media about the moon.
Hi, I'm Jacob Bleacher. I'm a geologist. That means I study rocks and dirt on the Earth and planets. This is Ask NASA. I'm here to answer your questions. What is unique about the surface of the moon? Well, the moon is quite unique from the Earth. It has no atmosphere. There's no air to breathe. What that means is that the processes that have occurred on the moon are all preserved there in the rocks. For instance, if you look at the moon from the Earth, you may see circles. Those circles are impact craters. Let me show you. Except, making craters is really dirty business. I need my crater-making poncho. Now we're ready. Let's pretend this is the surface of the moon. It looks a lot like this. That's one crater, but the surface of the moon has many more.
Oh, that was a good one.
On the moon, these craters have formed over time, and as you saw, material from each crater buries the previous ones, making this very rough terrain. In that terrain, at the pole, there are some craters that we believe have water ice trapped there, and they never see the sunlight. That's good for science, and could also be a resource that helps our astronauts survive. Why study moon rocks? Well, besides the fact that rocks are awesome, each rock is kind of like a person. It has its own fingerprint. We talked about impact craters. That's recorded in the rocks. Whether or not ice or water has been near there, that's recorded in the rocks. It tells us the history of the moon. What tools will astronauts use to explore the moon? Well, hopefully we'll have plenty of tools for them. For instance, something like this. This is a hammer like you would use here on Earth. It's a geologist's best friend. It helps us to break up rocks and select samples. We could also use things like rakes and shovels to help us find the right kind of material to bring home. Eventually, we could be using tools more like this. This tool is an X-ray fluorescence spectrometer, or XRF. An XRF basically shoots X-rays at a rock and then detects what comes back. And as I talked about before, rocks have unique fingerprints. This helps us to determine what that fingerprint is. Our astronauts will also use rovers, like this model that you can see right here. These vehicles are designed so that they can help us move around on the surface. Well, this tool is 3D printed, but this is just a model of an XRF. But right now, we're actually testing 3D printers in space on the International Space Station. It'd be really helpful if we can use 3D printers to design the tools that we need. How are we preparing astronauts to investigate the moon's surface? Well, we have to practice here on Earth. The way we do that is we talk to them in laboratory and classrooms, and we also take them out into the field, places like Hawaii or Iceland or Arizona. Places where there are similarities to what they might experience on the lunar surface. We're really excited to send humans to the moon with the Artemis program. That is a great question. The first thing that's going to be very different is that during Apollo, the sun was overhead. But at the South Pole, the sun is always going to be right on the horizon. That means we'll have really long shadows in areas that are very dark. It's going to be very different. We really are exploring a brand new terrain where no one has ever been. The studies we'll be trying to do are looking at and understanding perhaps the water cycle on the moon. And we really want to understand the processes that lead to that water being preserved there. Ooh, that's an intriguing question. First of all, we can see fairly deep into the interior of the moon by looking into craters. That's kind of our natural laboratory for getting at the inside of the crater. Every time a crater forms, there's an explosion that moves rock up and out from inside of the moon. So our astronauts walking around the rim of the craters can pick up rocks that came from deep inside. The bigger the crater, the deeper the rocks. Well, in fact, we are aiming for farther out. Eventually, we want to get to Mars. But first, we're going to go to the moon and learn some really important answers to questions that will help us survive the trip out to Mars here, because I guarantee you I'm going to have a lot of questions for them when they get back.
Do you have a question for NASA? Send your questions to our experts using hashtag AskNASA.
In 2024, NASA will be landing its first robotic rover on the lunar surface at the moon's south pole. This mission is called Viper, the Volatiles Investigating Polar Exploration Rover. This mobile robot will help us find and map locations of water ice, an essential resource for astronauts to have for long-term exploration. Viper will operate in an area near the western rim of the Nebulae crater. The landing site sits on top of a large, flat-topped mountain. Earlier this year, the mountain was given the official name of Mons Mouton. To see why, check out this next video.
Melba Mouton, an award-winning mathematician, computer programmer, and African-American trailblazer, is being honored with the naming of a mountain at the moon's south pole. To recognize her contributions to the agency, NASA proposed the name Mons Mouton for the lunar landing site and exploration area for Viper, its first robotic moon rover. In the late 1950s, Mouton became the head mathematician of a team of human computers that tracked communication satellites in Earth's orbit. She was instrumental in coding computer programs that calculated spacecraft trajectories and locations. Before retiring, she was recognized with a NASA award for her calculations of complex mathematical data that contributed to the successful Apollo 11 moon landing. Mons Mouton is a mountain that stretches roughly 2,700 square miles and has an elevation of more than 19,000 feet. It's about the height of Denali, the highest mountain peak in North America. The lunar landmark can be seen from Earth with a telescope. Viper will embark on a 100-day journey at Mons Mouton. The rover will explore the moon's surface to help gain a better understanding of the origin of lunar water, as well as map potential resources, which will help inform future landing sites under NASA's Artemis program. Melba Mouton's legacy lives on at the highest peak in the lunar South Pole, bringing NASA a step closer to its goal for a long-term presence on the moon.
From the Apollo missions to LRO, Viper, and Artemis, the moon is a central part of NASA's exploration efforts. But why is that? Here's a video with some answers and a preview of what's in store for the future.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel
deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. And as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Welcome back, and thanks for continuing to celebrate International Observe the Moon Night with us. Remember to check out our website, moon.nasa.gov/observe, and share how you're celebrating with the hashtag #ObserveTheMoon on social media. Our journey back to the moon took its first major step last year with the launch of the Artemis 1 mission on November 16th. Our next video recaps all of the sights and sounds of that incredible time.
50 years after we last left footprints on the moon, NASA's Artemis 1 is our first bold step towards getting us back there and pushing us farther than we've ever been before. You are looking at the world's most powerful rocket and Orion spacecraft live on Launch Pad 39B. The energy here is palpable as we attempt to make history today.
We're going to learn so much about the solar system from the moon and even about the Earth.
Range weather. Weather is go for launch.
The mission management team has been pulled. You have a go to proceed with terminal count.
On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, at this time I give you a go to resume count and launch Artemis 1.
4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together. Back to the moon and beyond.
SLS now traveling 607 miles per hour.
The harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. The first step in returning our country to the moon and on to Mars.
We are understanding now from the James Webb Space Telescope just how big and vast this universe is. There's a lot out there to explore. And this is the next beginning.
Orion is now flying free, attached to the European Service Module and on its journey to the moon.
Returning humans to the moon really makes us think about the lunar surface, what the rocks are like, the color and the texture of the lunar soil, and the deep craters, canyons, and soaring mountains. There are lots of reasons to see beauty in the moon's terrain, but at the same time, the moon is not as welcoming as Earth. There are areas that sit in total darkness with temperatures colder than all the known places in the solar system. It only has a thin atmosphere, called an exosphere, and it is not breathable. The craters, canyons, and boulders make the landscape very rugged, and some may see it as a bleak and lonely desert. The moon can be both haunting and beautiful, all at once. To give you a good sense of this perspective, we have something special to show you. Earlier this year, NASA Goddard partnered with the National Philharmonic Orchestra and composer Henry Dillinger on a performance called Cosmic Cycles, a Space Symphony, an eclectic mixture of visuals from our solar system and beyond set to music. What you're about to see is part of the performance focusing on the moon, set to synthesized orchestra music provided by Mr. Dillinger. It's called The Moon, Our Desolate Companion. We hope you enjoy it.
Hi, I'm Amelia Petro.
And I'm Noah Petro, the project scientist for NASA's Lunar Reconnaissance Orbiter and Artemis 3. And from both of us here in Alexandria, Virginia, we hope that you're all enjoying International Observe the Moon Night, have clear skies and a beautiful moon to look at. And so from all of us to you, happy International Observe the Moon Night.
こんにちは。私たちの名前はユーナとケイトです。僕たちは日本の東京都出身です。日本では毎年十五夜というお米の収穫を祝う行事があります。十五夜は秋の満月の日に合わせて行われ、日にちは毎年変わります。このように満月を見て楽しむことはお月見と呼ばれます。お月見で人々は月を表現したお団子を食べます。僕は月見団子が大好きです。Happy International Observe the Moon Night!
Thanks again for joining us for this International Observe the Moon Night broadcast. While people on Earth have a pretty good view of the moon, the astronauts that get to go there have the most spectacular view. With the upcoming Artemis 2 mission, 4 astronauts will get to go on a 10-day journey in the Orion spacecraft around the moon. This mission will pave the way for the Artemis 3 mission, which will put astronauts back on the surface, including the first woman and person of color. These will be incredible milestones and incredibly inspiring stories to watch. In this next segment, we'll introduce you to the Artemis 2 crew and show you the landing sites that are being considered for Artemis 3. We'll also show you how NASA will protect our astronauts from space radiation on their journeys to the moon and eventually to Mars. Let's take a look.
I'm Christina Cook. I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis 2 mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign of missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together.
When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
4-stage engine start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket
and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence
on the lunar surface.
We are ready.
We are going
to the moon
for all humanity.
We are Artemis.
Artemis is our 21st century return to the moon. Together, NASA, international space agencies, and a growing global space industry will explore Earth's nearest neighbor with advanced robotics and our next generation of astronauts. But where will our astronauts explore? The moon is a treasure trove of scientific discovery, and NASA has its sights set on the South Pole. This mysterious region features soaring mountains and deep craters, leading to unique locations that experience nearly continuous sunlight, in contrast to nearby depressions that never see the sun. Artemis 3 will mark humanity's return to the lunar surface for the first time since 1972. NASA has identified 13 regions near the South Pole that meet safety requirements for landing and present opportunities to search for lunar resources. Each region can also help us learn more about the history of the moon and gain a better understanding of our place in the solar system. These 13 candidate landing regions represent a diversity of features in the lunar South Pole, ranging from the summits of mountains rising miles above their surroundings to the rims of large craters. These features together act to both expose and preserve billions of years of geologic history. Using robotic orbiters and rovers, NASA and the global science community will continue to study these regions before selecting the Artemis 3 landing site. The astronauts selected for this bold expedition will literally and figuratively shine a light on some of the deepest, darkest areas of the solar system, revealing ancient secrets of the universe.
It's August 1972, and Ian Richardson, a future NASA scientist, is watching TV when the BBC announces
the interference is caused by solar activity.
He didn't know it then, but the sun had just erupted in one of the most powerful solar events ever recorded. There was no threat to humans because Earth's magnetic field deflects much of the sun's radiation. But the explosions were so powerful that intense radiation disrupted TV signals and caused radio blackouts. So what if you were outside Earth's magnetic field? On the moon and beyond, astronauts face the risk of extreme radiation exposure. Luckily, the intense radiation in 1972 occurred right between the Apollo 16 and 17 missions, where no astronauts were in their path. As NASA plans missions to go back to the moon and then onto Mars, predicting the sun's activity to protect astronauts from space radiation is one of our biggest priorities.
One of the biggest unknown factors about going to space is the radiation hazard from the sun.
This is Ian today, studying the effects of the sun, also known as the field of heliophysics.
The sun is always emitting radiation like the light we see, but certain energetic particles, like from the August 1972 events, can be far more harmful.
To be able to forecast solar energetic particles, we need to know how the sun energizes them. The sun is made up of electrically charged particles called plasma. As this plasma moves, it builds up energy inside its massive magnetic field. This energy is usually released in two types of explosions. Flares are intense flashes of light. Coronal mass ejections are giant eruptions of solar material.
These solar eruptions send shock waves across the solar system, accelerating particles as they go.
These are solar energetic particles, or SEPs. They consist mainly of protons and possess a lot of energy that can affect satellite measurements and humans.
SEPs can bombard you with a lot of radiation in a short period of time. They can penetrate your skin, damage your DNA, and increase your chances of getting cancer and radiation sickness.
But they don't occur with every solar eruption. Only a small number of flares and coronal mass ejections create SEPs.
So we're trying to predict when SEPs form and how they travel through space.
At NASA's Goddard Space Flight Center, the Community Coordinated Modeling Center, or CCMC, is dedicated to testing prediction models. Working with global partners, they use data from NASA satellites at different vantage points and models to figure out how solar explosions behave, including how shockwaves energize SEPs. And as we get better at predicting, we get more time to prepare.
Preparation for an SEP event, of which you may know that is already coming and perhaps the magnitude as well, The technique that you would want to use is to put as much mass between you and the source.
On the surface of the Moon or Mars, astronauts can go underground or build shelter with local materials. But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft. Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
In terms of radiation protection and radiation mitigation, the factor of time is extraordinarily important.
The Sun has a natural 11-year cycle that transitions through low and high activity, which is indicated by the number of sunspots on the surface. More sunspots mean more eruptions, resulting in a higher risk for SEPs. But during this increased solar activity, the Sun's magnetic field strengthens, enhancing its shield against another important source of radiation, galactic cosmic rays. These are charged particles travelling at nearly the speed of light that are thought to come from supernova explosions from within our galaxy and possibly further out in the universe. If solar energetic particles are intense sporadic storms, then galactic cosmic rays are a constant drizzle. Galactic cosmic rays are more sparse, but also much more energetic. They include heavier elements that can penetrate through vast amounts of materials. Understanding the rate of galactic cosmic rays helps us determine how much time astronauts can spend in space safely. To date, humans have only been on the lunar surface for a cumulative total of about 12 days. A trip to Mars will take 6 to 10 months each way. That means even more radiation exposure, and so NASA is doing work to prepare for that.
The Moon is going to be a test bed for us in order to be able to prepare for Mars. The more that we understand the impact and the duration of radiation on the Moon, the more we can extrapolate that to the length of time that we will be spending in transit and on the surface of Mars.
The Sun and the Moon interact with the Earth in many ways. The Sun gives us heat, the Moon helps stabilize our planet's tilt, and both influence tides in the ocean. The Sun and Moon are prominent in our daily lives and in our cultural traditions around the world. And every so often, these three celestial bodies align to create a phenomenal sight in our sky. I'm talking about a total solar eclipse, where the Moon totally blocks out the bright disk of the Sun for a short period of time. The next one takes place on April 8th, 2024, and will be visible in parts of Mexico, the United States, and Canada. Safety is our #1 priority when viewing a total solar eclipse. It's not safe to look directly at the Sun without specialized eye protection or filters if you are viewing through a camera, binoculars, or a telescope. It's only during the moments of totality, when the Moon completely blocks out the bright disk of the Sun, that you can take a look without protection. You can visit solarsystem.nasa.gov/eclipses to learn about solar eclipses and how to observe them safely. Eclipse glasses are great to have, or you can build your own indirect viewing method like a pinhole projector. Our next set of videos will show you the path of the 2024 total solar eclipse and how you can build your own pinhole projector at home.
Solar eclipses occur when the Moon gets between the Earth and the Sun, allowing the Moon's long shadow to intersect the Earth. This is the April 8th, 2024 total solar eclipse. The central part of the shadow, called the umbra, sweeps across the surface at more than 1,500 miles an hour. It would move even faster if the Earth weren't also rotating in the same direction. The path of the umbra is known as the path of totality. People in that path see the Moon completely block the Sun, turning the day into night and revealing the Sun's outer atmosphere, the corona. The umbra is over land for just an hour and 40 minutes before moving into the North Atlantic and then skipping off the edge of the Earth.
Hi, my name is Parker, and I'm going to teach you how to make a boxed pinhole projector. To get started, you'll need a cardboard box, cereal boxes or shoe boxes work great. You also need scissors, aluminum foil, a pencil, a push pin, some tape, and a white piece of paper big enough to cover one end of the box. Start by tracing one end of the box on the white sheet of paper. Then cut out your shape and place it inside of the box on the same end you just traced. Next, cut 2 square holes on the opposite end of the box, one on the left and one on the right. If you're using a cereal box, tape up the middle to help everything stay together. Now cover one of the square holes completely with aluminum foil. Use tape to help the foil stay in place. Finally, take the pushpin and punch a very small hole in the center of the aluminum foil. Ta-da! Always remember, you should never look directly at the sun because it's very dangerous and will hurt your eyes. To use your boxed pinhole projector, stand with your back to the sun. Then hold the large square hole up to your eye and move the box around until you see the sun. Project it on the paper. Watching a solar eclipse is a great way for anyone to do science. But remember, you have to be careful. Stay safe. Happy eclipse watching!
Well, that concludes our program. Thanks to each and every one of you for watching and celebrating International Observe the Moon Night with us. We hope that you have a chance to go outside and take a look at the moon in the sky or find your own special way to connect with the moon. We also hope you'll share how you are participating with us through moon.nasa.gov/observe and by tagging Observe the Moon on your favorite social media platform. The website also has a survey you can fill out to help us make this event even better in the future. A final big thanks goes to the Solar System Exploration Division at NASA's Goddard Space Flight Center and to NASA's Lunar Reconnaissance Orbiter for sponsoring International Observe the Moon Night. We really appreciate this opportunity each year to share highlights of lunar science and exploration and to celebrate the moon with all of you. Thanks again for watching.